Today I want to talk about continuous delivery topic, which is one of the best software engineering practices. Before we delve into the details of it, let's understand why continuous delivery is so critical and important. I think this quote captures the very essence of what continuous delivery really means to a business. For evidence, we have to look no further than the tech giants like Amazon, Netflix, Google, and the like. So, what do they all have in common? They are able to deliver business values to their respective customers faster than anyone else in their domain and doing so continuously. Fortunately, all of these tech companies not only pretty vocal about their engineering practices but also opened up some of their best tools and technologies for the rest of us to take advantage of and benefit from. So, what is continuous delivery? Essentially, it is an approach that consists of two fundamental engineering practices called continuous integration and continuous deployment, and they are commonly known as CI CD in short form. Now, let's take a quick look at the mechanics of continuous delivery. The first step, the business requirements are broken down into stories, which would then be implemented as a working software by the development team. Second step, during the development, developers should check in their source code into a version control system after going through the code review process by sending pull requests, have them reviewed by their team, and merge them once the change is reviewed. Most modern version control systems, such as GitHub, Bitbucket, cloud source repositories from GCP, code commit from AWS, make this code review process quite simple and automated. The third step is continuous integration. Jenkins is an open source, well known, and one of the mostly used software in this space. The way it works is whenever developers check in their source code, it pulls the latest code from the version control system and starts building, which includes compiling the source code and running all the tests and sends a notification to the development team if the build is broken. Otherwise, proceeds to the next step. Let me also briefly point out SonarQube, which is an interesting piece of software that could be integrated with your build system. It scans the code base and produces a lot of quality metrics such as coding standard deviations, number of bugs, security vulnerabilities, etc. And it is very useful to improve the code quality. The fourth step, once the build is successful, the artifacts, assuming it is already containerized, the Docker images can then be stored in artifacts repository, which also supports versioning. JFrog, GCP, and AWS also provides container registry solutions. And the fifth step, artifacts are then deployed to different environments such as development, QA, staging, and eventually to the production. Deployment technologies such as Puppet, Chef, Ansible, and other solutions are already available, but I personally like a couple of them. One is the Terraform, which is from HashiCorp. It could be used for infrastructure provisioning. And the second one is Spinnaker, actually originally originated from Netflix, later adopted and supported by Google. It is a sophisticated software that supports features like blue-green deployments and etc. And both the Terraform and Spinnaker are open source solutions. And the last phase is operating environments. It could be your on-prem data center, cloud, or both. So Kubernetes became the de facto standard as a container orchestration engine that provides a nice abstraction layer that enterprises can target their workloads to. And most of the cloud vendors are supporting them as a managed services, especially with the solutions like GKE on-prem, AWS Outposts. With that solutions, enterprises can now develop and operate their environment consistently and gives us a nice user experience across both on-prem and the cloud. So far we talked about deploying functional features, but you may ask what about the non-functional features or cross-cutting concerns such as logging, monitoring, tracing, etc. Well, that's where the Istio comes in. Istio is an open source solution. Essentially, it instruments your code, applying security policies at runtime, and also provides telemetry data, that is, logging, tracing, etc., without coding. That means It allows the development team to focus on differentiators, which is building functional features, instead of them spending time on addressing cross-cutting concerns. And that's a huge deal if you think about it. The fancy name for Istio is called Service Mesh, or also known as Sidecar Pattern. Once we have telemetry data, it can be integrated with other solutions and centralized for visibility. On open source side, we have ELK Stack, Zipkin for tracing, Prometheus for monitoring, and Grafana can be used for visualization. GCP also provides a solution called Stackdriver, and on the AWS side, they provide CloudWatch and X-Ray, and these are all a single pane of glass solutions that could be used for monitoring your operating environments. Now, once the feature is deployed and ready, then it is simply up to the business owner's decision to make it available to their customers and get their feedback and repeat the same cycle. Hence, it's called continuous delivery. Hope this is helpful, and thanks for watching. In the next session, I will walk you through the process with a concrete example. Till then, stay tuned.